In this video, we are going to understand what is a functional group. The functional groups that we'll be studying in this video or in class 10, the heteroatoms like chlorine and bromine only, alcohol, aldehyde, ketone, and carboxylic acid. Now, before we understand the definition and what is a functional group and their characteristics, let's begin with one such example, like to understand how the functional group alcohol is formed. So what I'll do here, let's say if I begin with writing a saturated hydrocarbon having a single bond between carbon-carbon atom with one carbon atom. And definitely you must be knowing its name. It is clearly methane, right? This is methane. Now, if I write its structure, before that, you should also know that the structure of alcohol is single bond OH. Now, if I write down the structure of, if I draw the structure of methane, methane with one carbon atom and four hydrogen, right? So what in case this, if I remove this one hydrogen atom, right, and place this OH, right? I'm going to place this OH here. Let's say I create a copy over here. I'm going to paste it over here. Now check. In this case, now the compound name of the compound should change, right? So the name of the compound after this is going to be what? You will say it is CH3, right? This is CH3. First of all, I'll talk about its molecular formula, right? Earlier it was CH4 and now it is CH3OH because of this OH. So what OH actually has done, this OH functional group substituted this hydrogen in the carbon chain. And therefore, many things will be changed. The first thing that has changed is the molecular formula. Now it is CH3OH, right? And similarly, the name is also going to change. So we had the name methane here. We had the name methane. And now we will attach a suffix called OL. And the name of the compound from methane will turn as methanol. So this is how the first member of this alcohol functional group is formed, and this is methanol. Now let's make other structure similar to this. Now I'll take the second member here of alkane series. It is what? C2H6, and the name is clearly with three carbon atom is going to be ethane. And if I have to draw its structure, I'll say with two carbon atom, the first carbon atom is bonded with three hydrogen and the last also with three hydrogen. Now, same as the previous case, if I displace this hydrogen by this OH as the functional group, I'll take a copy of this and will paste over here. Now check. So now what are the things that's going to change here? Number one is its molecular formula and the structures, right? So structure is now has changed. So we'll call this as, you may write this as CH3 for this part, CH2 for this part, and OH for this. Or alternately, you may also write C2H5 OH. Now, as I can see that here also this OH functional group has substituted for hydrogen in this carbon chain. And what are the things going to change? Number one, the molecular formula has changed, its chemical properties will change, and the name. Now, the name was ethane earlier. Now, this hydro E will be replaced by the suffix OL, and the name of the compound will become ethanol. And that's how the second member of this homologous series. Well, the term homologous series will be clear. It's just that you have to remember it's a series of compound having the same functional group. We made ethanol. Now, next, I'll make what? With 3 carbon atom, that is from propane. So propane is what? C3H8. If I write down the structure of propane, I'll write C3 and H, I'm counting it. It's coming to be 8. Now, similar to all previous 2 cases, I'm going to displace this hydrogen. This hydrogen will be substituted by this OH over here, and the compound will change now. So from it was what? It was propane. Sorry, it was, yeah, it's propane. It is propane. And as I said, this E will be displaced by what? OL, and the compound will be now called as propanol. With this molecular formula, you may write either CH3, CH2, CH2, OH, or you may write C3, this is C3, H7, OH. And name, as I said, it is now propanol. Right. Similarly, you can make for butanol, pentanol, and hexanol. The important thing to observe here is what? When we talk about the functional group, over here it is an atom, a group of atom like OH. Sometimes it can be a single atom, heteroatoms we say, could be Cl and Br, which will substitute for hydrogen, in the carbon chain and confer specific properties to the compound. What does it mean here? That when this functional group displaces the hydrogen, if I start with the examples we did here, like in this case, as you can see earlier, I took what? I took propane, right? I took propane, and because of the substitution of OH, now by displacing this with OH, this OH will confer a specific chemical properties to the compound. So we can say that the properties of propane will now change, and it will behave like an alcohol. That means it will have all characteristics of alcohol. So we can say that the chemical properties is now decided by this functional group OH, while the physical properties will be because of this carbon chain. Now we'll do more examples here of the functional group, and then we'll come down to the definition and the other characteristics of a functional group. Now next I'm going to take aldehyde. The next functional group which we are going to study here is about aldehyde here, and aldehyde with its formula C double bond O single bond H. You should remember here this carbon includes that carbon present in the carbon chain. Let's do some example here. I'll first begin with us 2 carbon atom, then we'll come back to the with 1 carbon atom. So first I'll write a compound, that is, say I wrote ethane, and ethane, if I draw this structure, is going to be what? It is C, first carbon atom bonded with 3 hydrogen, right? Now, as I said here, this carbon includes the carbon present in the carbon chain here. So we are going to displace this. We are going to displace this whole thing. And we are going to attach the aldehyde functional group. So this is the functional group here. Let's say I take its copy and attach over here. Now, if I attach this over here, you can see here what things are going to change. Things that are going to change are many things. First, I'm going to change its molecular formula. Now, the new molecular formula you should write as CH3. As I said, aldehyde is written as CHO, right? And we cannot change the order, right? It has to be CHO. Now, when it comes to name, it was earlier ethane. Now, like previous case, we'll be displacing E and we'll add a suffix called Al. So the name of the compound will be, this is called ethanol, right? The name becomes ethane now turns out to be becomes ethanol. Now, if I have to make a compound with a single carbon atom, first I'll write C. And as you know that with one carbon atom for aldehyde, there is a double bond O and single bond H with a place left only for one hydrogen. And as I said, for aldehyde, it is what? CHO, and this is not going to change. Therefore, we'll be writing HCHO as the name of this molecular formula of the compound. As you know, with a single carbon atom, the compound was methane, displacing E and adding the suffix Al is going to be methanol. So that should be the name of the compound. So here too you can see that we are getting a series of compound. These series of compound with the same functional group present here is what we say as a homologous series. Now next I'll take one more example with three carbon atoms. So what I'm going to do is to write three carbon atom and say all of them had, well, I'll do alternately. Let's say if I'm asked to make that was ethanol, methanol is done. And if I am asked to make propanol, so what I'll do first, for propane, there are three carbon atoms. So first I'll write three carbon atom in a straight chain. And since I know it's going to be aldehyde, so I'll first draw double bond O and single bond H here. And whatever the unsatisfied valencies are there with carbon, will attach hydrogen over here. When it comes to name, either I can write CH3, CH2, but CHO has to be like this. Or I may club all these together and write this as C2H5 and CHO. Now, name, as I can say, it is propanol, right? That's how we made. And similarly, you can make other compound. Important thing to consider here that all of them has the same functional group, CHO, and the characteristics, that is the chemical properties of these all compounds will be similar. And the physical properties will depends upon the carbon chain present. We'll discuss more about it, but more, and first of all, let's do more questions of functional group, and then we'll come to the characteristics. So the next in the order, I have taken carboxylic acid. First of all, you should know that carboxylic acid structure is like C double bond O, single bond OH, and it always joins at the end, right? So first I'll make the compound with two carbon atom. So for that, I'll first write two carbon atom in a straight chain. From here, it is clear to you that the functional group here is carboxylic acid with double bond O and single bond OH, right? And the other unsatisfied valence is what I'm going to say here. First of all, this is the functional group here, right? You can see this is the functional group. And whatever the unsatisfied valencies are there with the carbon, as you can see, this carbon has four bonds present, like 2 plus 1, 3 plus 1, 4. So no space for attaching more bond. And this is how the other carbon atom gets satisfied. Now, beginning with its name or the molecular formula, let's say first I indicate the functional group I have taken. Right. This is carboxylic acid. Writing as per its name, you should know that the COOH will come for this. Right? And we cannot change the order. So when it comes to writing its formula, it has to be one unique name, that is CH3COOH. Its molecular formula. Now, next is its name. As far the name is concerned, there are how many carbon atoms? Two carbon atoms. So we should start with the word eth, right? And end up writing ethane. Now we'll replace this E here and we'll add oic and acid. So let me show you. It is oic acid. Oic, and then giving a space is acid. So this becomes ethanoic acid. Now we'll do with the first member, what's one carbon atom of this functional group. Was that carboxylic acid? Now check here. For carboxylic acid, we have this as the structure that is that gone? Yeah. This is single bond, C double bond O, single bond OH. As you can see, this carbon has one unsatisfied valencies, which will be compensated by attaching one hydrogen. This way, as I said, COOH, we cannot disturb this pattern or the convention of writing. So we'll write H in the beginning, HCOOH. Now, since it is made up of single carbon atom, you may first write methane and then remove one E from the end and add the suffix oic and acid. This turns out to be methanoic acid. Can do one more. Let's say if I have to make with four carbon atoms. So first I'll write, or I just take a different way. If I have to frame what? Butanoic acid, right? I'm going to make butanoic acid. So it's butane, then E removed, oic is added and acid is added. So for butanoic acid, I'll first write four carbon atom in a straight chain, keeping in mind that the last carbon atom has to be bonded with double bond O and single bond OH. Then the other unsatisfied valencies will be taken care by hydrogen like this. That should be the structure. When writing its molecular formula, as I said, this COOH should be written at the end. So you may write them this other compound together or you may split it. So you may write this as with three carbon atoms C3H7, right? Yeah, 7 hydrogen and COOH, or you may split and write as CH3, CH2, CH2, but COOH will come together. That's how butanoic acid is formed. Now we'll take next is ketone. Now for the ketone functional group, what you have to remember is number one, the structure. You should know that the ketone is C double bond O, but important thing to consider here that it has bond on either side. That means there must be minimum three carbon atom present for the formation of this compound. As you can see here that there is a bond on either side. Unlike alcohol, it cannot join at the end. So by that it means to say that for ketone to be formed, the compound, the minimum number of carbon atom is 3. That's why its first member will start with 3 carbon atom. Right. So let's say if I have a joint ketone, I can put hydrogen for removing the unsatisfied valencies with carbon. So this carbon also have 4 bonds. Now when it comes to naming, we will not merge this with other carbon. This should be written separately, CO, and this is CH3. That's the unique name of this compound, I mean molecular formula. But when it comes to naming the compound, it's made from 3 carbon atom, right? So first I'll write propane here. First I wrote propane. Then I'll be removing the last E and will be adding a suffix called 1. But when it comes to reading its name, you should read this non together, not one. This is propanone, right? Now, once we have done propanone, we can make butanone, pentanone, and hexanone. So now I'll take 4 carbon atom in a straight chain. So we have a choice here. Either the double bond can be present with this or can be this. This is because the carbon here, as you can see, this carbon ketone forming has a bond on either side with carbon only. Now I'll put hydrogen here. The next carbon atom, no unsatisfied valency. This has two unsatisfied valencies. This has three. So when it comes to writing its molecular formula, I'll first write CH3. This should be CO, as I told you that this cannot merge with other carbon atom. This you may write C2H5 or you may write CH3, sorry, CH2. CH2, CH3. And as for the name is concerned, the name of this compound, it's made from butane, right? So first I'll end up writing butane, removing E and writing a word 1 over here. So this become butanol. Now then we have what more to do is heteroatoms. Let's do it. The next we are going to do heteroatoms, parts of functional group only. And in class 10th, we are doing heteroatoms halogen, that is chlorine and bromine only. So let's begin with chlorine. Now, if I have to find the first member, including the heteroatom chlorine, for that what I'll do? First, I'll write carbon with 4 hydrogen, right? And then I'll replace this hydrogen with chlorine, right? So what things will change? Number one, its molecular formula now will become CH3Cl. And it was initially methane, so let me write on methane here. But unlike the previous functional groups that we did, this time there will be a prefix instead of suffix, right? And the prefix will be chloro. So it should be called as CHLORO. Chloromethane will be the name of the compound. Now, instead of chlorine, if it is bromine, then we'll name it as bromomethane. Coming to this next, that is with 2 carbon atom, if I have to mix, so I'll first write 2 carbon atom in a straight chain, second member of this. Now, instead of chlorine, if I have to take bromine, I'll attach Br at the end. Naming this compound will be, this is what Bromo will come as a prefix here. So this is Bromo. And there's what, 2 carbon atoms, so it's ethane, right? This is bromoethane. Likewise, you can make a bromopentane, bromohexane, chlorohexane, chloropentane, chlorobromine, and all. Now let's talk about the characteristics of this functional group. Now, as for the definition of this functional group is concerned, so what we have just observed that it can be an atom, as in case of chlorine or bromine, or can be a group of atom, as in case of alcohol, right? That is C double bond OH. OH in case of, could be group of atom, as in case of ketone also belongs to group of atom, right? So it can be an atom or a group of atom which substitutes for what? Hydrogen in the carbon chain. As you can see in everywhere, this hydrogen was substituted by one of these, like can be an atom or a group of atom, and confer specific properties to the compound. By that, it means to say that if the alcohol functional group present, then it will have some similar chemical properties. Now, let's write on the one such series. If I write on, let's say, if I write methanol, it is what? CH3OH. Then the second member is C2H5OH, that is ethanol. Third is what? C3H7OH, propanol. C4H9OH, butanol. C5H11OH, that's 11. Pentanol, and this is C5H13. 13 OH, that is hexanol. Now you should know that the chemical properties of these compounds will be decided by the functional group present, which is alcohol here. And the physical properties will be decided by the carbon chain, right? So first thing that you have to remember. Now check one more time that if I choose any one member from here, let's say I took this one. I took this one. One more time. I took this compound. Give me a second. I just took this compound. What you can observe, if you see the difference of this compound with its preceding or succeeding member, check here. There's a difference of CH2. There's a difference of one carbon. There's a difference of one carbon and two hydrogen. Check here. There's one carbon more and two hydrogen more. Or you may check from here with this. So each member in this is what homologous series, a series of compound, which I said, same functional group present. So each member differ from its succeeding and preceding member by CH2 group, or you may calculate its molecular formula. What is the molecular formula of carbon is 12 and that of hydrogen is 1. 1 into 2 is 2, that is 14U. Here U for unified mass, right? So that is earlier it used to be AMU, now it is unified mass. So each member differ from its succeeding or preceding member by CH2 group, or we may say 14U. Further, as you can see here that as we go down this group, like starting from above to below, as we are going down this group, you can see that the number of bonds increases. And therefore, you can say that the more amount of energy is needed to break this bond. And hence, we say there is a gradation, gradation, gradation in the physical properties of the compound. That means there is a gradual increase in its melting point and boiling point. This is because you can understand from here that there is a number of bonds increases. Now let's do some question here. What are the questions that I have taken? Identify the number of carbon atoms in the compounds. Where is the question? Okay, maybe below. Let's check from here. The question here, if I take the first one, well, name the compounds here. The first compound is what? This is what? We can see the functional group here is OH, right? The functional group is OH here. And how many carbon atoms are there? There are two carbon atoms. So two carbon atom is what? Eth, right? Two carbon atom is ethane. And I'll remove this E and will write OL. That's what? Ethanol. For the second one, is aldehyde is present with two carbon atoms. So again, it is ethane. And this time you'll remove E and will add a suffix called OL. So, this time it is AL, right? Not OL. It is AL. So this is ethanol.